students, today we will be studying a very important topic from chemistry, that is mole concept. Now always remember students, mole is just a number which is called as Avogadro's number, and the number is 6.022 into 10 to the power 23. And remember students, 1 mole 6.022 into 10 to the power 23 particles. Now it can be anything, any particles it can be either atoms or molecules or ions. Okay, so likewise ions. Let us take one example. Now all of you know children that 1 dozen, if I take 1 dozen of eggs, the number is 12. That means total number of eggs present in 1 dozen is equal to 12. If I replace this eggs with apple, then again 1 dozen of apple will be 12. Same way if I replace an apple with balls, so suppose if I take 1 dozen of ball, that means again the number will be 12. So in short, as we know that 12 numbers are present in 1 dozen, same way in 1 mole 6.022 into 10 to the power 23 particles will be present. And the particles, it can be either atoms, molecules or ions. Clear? Now let us proceed ahead. Now let us try to understand the difference between molar mass and atomic mass. Now if I talk about molar mass is nothing but mass of 1 mole of a substance. Mass of 1 mole of a substance in gram. Now we know students that mass of 1 proton plus mass of 1 electron, it is equal to 1.66 into 10 to the power minus 24 grams, which is equal to 1 AMU. AMU is nothing but atomic mass unit. Now remember students, AMU is nothing but atomic mass unit. Now remember students, the mass of 1 electron is very, very small. So we can just neglect the mass of electron and we are going to only write down the mass of proton, which is 1.66 into 10 to the power minus 24 grams, which is also equal to 1 AMU. Now mass of 1 hydrogen atom is equal to 1 AMU, which is equal to 1.66 into 10 to the power minus 24 grams. Now let us consider mass of 1 hydrogen. Therefore, 1 hydrogen atom is equal to 1.66 into 10 to the power minus 24 grams. Therefore, X hydrogen atom is equal to 1 gram. Which can also be written as X is equal to 1.66 into 10 to the power minus 24, which is equal to 0.6022 into 10 to the power 24. I can also convert this thing into 6.022 into 10 to the power 23 atoms. So finally I can say children that 1 gram is equal to 6.022 into 10 to the power 23 atoms, which is nothing but it is equal to 1 mole of hydrogen atoms. Clear? Let us now solve one more question. mass of one sodium atom. Let us now solve one more question. Mass of one sodium atom is equal to 23 AMU. Therefore, we can write down one sodium atom is equal to 23 into 1.66 into 10 to the power minus 24 grams. Therefore, we can write down X sodium atom is equal to 23 gram. Similarly, X is equal to 23 upon 23 into 1.66 into 10 to the power minus 24 grams. Simply you need to cross multiply, which is equal to 1 upon 1.66 into 10 to the power minus 24. Finally, we will be getting 6.022 into 10 to the power 23 atoms. So again, we can write it down as 23 gram of Na is equal to 6.022 into 10 to the power 23 atoms of Na, which is equal to 1 mole of Na. Which is equal to 1 mole of Na. Let us now take one example for a molecule. So same way we are going to solve for a molecule. Mass of one HCl molecule is equal to 36.5 AMU. Therefore, I can write down 1 HCl molecule is equal to 36.5 into mass of 1 proton, which is equal to 1.66 into 10 to the power minus 24 gram. Same way, X HCl molecule is equal to 36.5 gram. Again cross multiply. So we can write down X is equal to 36.5 upon 36.5 into 1.66 into 10 to the power minus 24, which will be equal to 1 upon 1.66 into 10 to the power minus 24, which is equal to 6.022 into 10 to the power 23 molecules. 6.022 into 10 to the power 23 molecules. So finally, I can write down, students, that 36.5 gram of HCl is equal to 6.022 into 10 to the power 23 molecules of HCl, which is equal to 1 mole of HCl. So always remember, students, 1 mole of any particle, I write down 1 mole of any particle will be equal to 6.022 into 10 to the power 23 particles. Okay, and those particles, it can be either atoms, molecules, or ions. So this is called as mole, 1 mole, which will be equal to molecular weight or atomic weight in grams. Okay. Now let us try to understand the difference between molar mass and atomic mass. Now if I write down molar mass of oxygen atom, then it will be nothing but, then if I write down molar mass of oxygen atom, it is nothing but mass of a 1 mole of oxygen atom, which is equal to 16 gram. Always remember, molar mass will be written in terms of gram. Now same way, if I write down atomic mass of one oxygen atom, atomic mass of one oxygen atom, so that will be nothing but mass of one oxygen atom, which is equal to 16 AMU. So understood? 16 AMU is the mass of one oxygen atom, whereas 16 gram is equal to, now let us learn the formula for mole. Now 1 mole of a substance is equal to 6.022 into 10 to the power 23 particles if it is in grams, which we can also call it as molar mass. Same way, 1 mole of a substance, it occupies 22.4 liter at 1 atm, that is 1 atmospheric pressure, and temperature is 273 Kelvin if it is in gas. Clear? So remember this formula. The next formula for mole is mole of atoms is equal to mass in gram upon molar mass, which is also called as a gram atomic mass. So this is for atoms. Same way we can also write it down for molecules. So mole of a molecule is equal to mass in gram upon molar mass, which can also be written as gram molecular mass. Let's find the molar mass of nitrogen. Now in order to find out the molar mass for nitrogen, first of all you should know the atomic masses. The atomic masses or the atomic weight is already given in the brackets. Now for nitrogen, we know that the atomic weight for nitrogen is 14. So that will be equal to 14 gram. So for nitrogen, the molar mass is how much? It is 14 gram. Clear? Same way, I can write down the molar mass for nitrogen molecule. Now we all know, children, that nitrogen molecule, it contains 2 nitrogen atom. So simply you need to multiply it with 2. So 2 into 14 will give me 28 gram. So this will be the molar mass for nitrogen molecule. Likewise, you can solve for the rest of the elements or molecules. Phosphorus, again it is 31. So 31 gram. For hydrogen molecule, it will be 2 gram. Same way for oxygen, it will be 16 gram. Then for oxygen molecule, it will be 32. Then same way for sulfur, the atomic mass or atomic weight for sulfur is 32 gram. And for S8, it will be 8 into 32 grams. Clear? So this is how you are going to solve the concept for molar mass. Students, now let us solve few questions on mole concept. Now the first question is, find out the volume and mole in 56 gram of nitrogen at STP. Let us try to solve the question. Now we know that 28 gram of nitrogen, okay, 28 gram of nitrogen, it occupies 22.4 liter at standard temperature pressure. Therefore, 56 gram of nitrogen occupies 22.4 upon 28. Simply you need to cross multiply into 56 liter. which is equal to 44.8 liter at STP. Okay, so the answer for volume in 56 gram of nitrogen is 44.8 liter at standard temperature and pressure. Now let us try to solve the next question, that is the number of moles present in 56 gram of nitrogen at STP. So again we know that 28 gram of nitrogen molecule, it is nothing but 1 mole of N2. Same way I can write down 56 gram of N2 will be equal to 1 into 56 upon 28, which is equal to 2 moles of nitrogen. Okay, you can also use the formula, that is number of moles is equal to mass given upon molar mass. In the above question, the same way, volume given upon molar volume. Okay, so this is how you can solve the question.